Drain fabrication, okay? I saw this in the house that we're staying in right now. Of course, first thing I did is went and looked at all the air conditioners, and I don't think you guys installed them, so it's okay. One of the first things I noticed, and one of the biggest things that get confused, is this idea of trapping and venting, how that all works. Now again, in your market, it's a little different than ours. In our market, we're almost always just going straight outside, right? And in a lot of cases, we're actually going down underneath and then back up, which is a bad design, and it's just a thing we do in Florida because we do lots of dumb things in Florida. But for your market, you're going to see a lot of cases where you have traps at the air handlers. That's at least how it is where we were. Is that true? You see a lot of traps at the air handlers. Okay. Couple key points here. First of all, you need to have fall across the entire system. Everybody knows this, right? But how much fall? 1/4 inch per foot is about what you look for. Some codes in the US will say an 1/8 inch per foot, but you really want to have, for every foot of run out, you want to see it drop about 1/4 inch minimum. It can be more than that. Some people will talk about, oh, it could be too much. Well, that's in plumbing where you have solids. When you have solids, you could actually get too much fall where the water rushes by and the solids don't go with it. In HVAC, that's not as big of a thing because we shouldn't really have, you shouldn't be crapping in the drain line. That would be a bad thing. One of the biggest mistakes that people miss is double trapping and vents and how that all works, okay? So you want one trap and only one trap. The only time that there's an exception is if you have a system where you have multiple systems going into a common drain, and then you might have more than one. You might have traps in the individual drains, and you might have one in the common drain that they connect to. That can happen. But here's a really important thing. Before your trap, you have a clean out. Do you guys use prefabricated traps, like easy traps or anything like that? Do you tend to use those? Okay, so that's built in. It's baked into the system. You got a clean out. But after that, you should really have a vent, okay? And a vent is open and it stays open and it's tall enough that it gets above the drain pan, right? That's really, really important, that last part that I just said. Because if you have a vent that's not taller than the drain pan, what's going to happen when the drain backs up? It's going to overflow all over the place. If it's taller than the drain pan, it's not going to make a difference, right? And what that does is it de-risks you in case there are double traps later on. Because a lot of times if you're running across an attic, for example, you may have a drain that has a long horizontal run, and it'll kind of get bellies in the drain over time. And by having that vent after the trap, it breaks that air bubble and allows it to continue to drain. Will you have drains that work without a vent? Sure, they'll work most cases, but a vent is the best practice. You have a trap, and that trap, the outlet is lower than the inlet, right? You understand that it's not a running trap like this. Outlet's lower than inlet, and the whole thing is pitched 1/4 inch. That makes sense? So it's not level here, it's pitched 1/4 inch, and the outlet is lower than the inlet, and at the outlet you have this vent that goes nice and high. And it doesn't matter, you could pipe it all over the place. It doesn't matter, just so long as it's above and air can escape. That's all that is.
So one decent important thing here is that you probably don't have this problem, but a lot of drains here, a good amount, they go right into the plumbing.
To the plumbing, there you go.
Yep. To make sure that's not the case before you put a trap on it.
Before you put a trap or a vent. The vent, right. You need to have a trap, but no vent. Good point, because you don't want sewer gases escaping up that vent, right.
The same thing goes for positive pressure in your handlers. Like trains, that you don't have to use a trap,
right.
But you need one if it's going to the plumbing.
Good point, yep, that's a really good, does everybody understand what he just said? That's a really key point. In Florida, that's against code, so we never run into that. But here, that's a very specific thing. If you're going into something that contains sewage, it not only is it important that you don't have a vent, it's important that you always have a trap. And that trap does not even dry out on you, right? If that trap dries out, you're going to get sewer gases coming back in. Have you ever walked into a restaurant or a public bathroom or a public kitchen and it smells like absolute refuse? It smells like absolute... Most cases, what that is floor drains that have dried out or they're untrapped, improperly installed, and sewer gases are coming up through, or sinks or anything like that. I mean, and it is absolutely disgusting. And you can imagine that pulling right into your air handler, right into your airstream. I mean, that's just, that's disgusting. So for sure, exactly what Simon just said. Go ahead.
Yeah, what happens a lot of times, some of the issues that we face here when the drain goes into the vent shaft, so the buildup of sludge is frequent.
Yeah.
So we find that drains that run inside vent shafts, 1 month, 6 weeks after maintenance,
Yep.
it's like a buildup of sludge.
Yep. Yeah, and it's tricky. You know, drain cleaning and drain basic practices, they're really tricky. And again, like this is where I can't. Every market's a little different. The products that you have access to are different. A couple general things. If you are going to use any sort of chemical for clearing drains, do you ever use any sort of chemical like Drain Solve or anything like that to do it? Vinegar's. What was that? Yeah. There are a lot of different types of chemicals. Like Drain Solve is a product made by New Calgon specifically for condensate drains, and that stuff is toxic. I mean, like you get that on your hands. We had a guy get it in his eyes. I mean, it is horrible. So again, when you're working with any kind of chemical like that, if you're doing an install, sometimes you can justify it because you're like, I'm not doing this in a maintenance. I'm just trying to get this all clear. Now, you should not be making that decision. That needs to be made with leadership because there's a lot of factors there. But if you are going to use it, put your PPE on, put gloves on, put glasses on, cover your skin, make sure, because again, you get a little blowback on that stuff, it gets on you. Also, make sure if you're using chemical, you know for a fact where it's going, right? Because if you think it's going into a sewer stack or something, but it's actually going outside and it's going to spray on someone's Porsche or something, you know, or in their, you know, their treasured azalea bush or whatever you have, it can, you know, it can cause damage. So always think about that if you're using chemical. Other options would be things like using nitrogen or a combination of water and nitrogen or a vacuum, depending on what the situation is. And the term that I always use when it comes to any sort of cleaning practice within condensate is clean it until it's clean, right? It's so stupid, it says here, but you see so many people, well, I ran a gallon of water through it. Was it clean? I hooked a shop vac up to it, but was it clean? I've used nitrogen. Was it clean? Well, how do you know if it's clean? You look, right? And a lot of times with your clean out tees or wherever, you can get a flashlight and just look, which is why I'm a big fan. And again, I don't see a lot of them here, but I'm just going to give you what I'm a big fan of, and you can do whatever you want, is flashlights, old school flashlights on you. A lot of people use their phones, and that's fine, but the problem with your phone is that like it's not convenient. Like it's in a weird spot, right? And so I'm a really big fan of flashlights, especially with things like drains, the old mag lights or something similar, because you can get in there and you can actually look. Like, do I still see buildup? Okay, I may need to disassemble it then. I may need to run brushes through it. We keep brushes that are, I was going to bring some and I forgot, but they're actually aquarium brushes. They're really flexible brushes with the brush on the end, and you just get in there and brush it. A lot of times guys will use, like, they'll take stat wire. And people have all kinds of weird workarounds. They'll take stat wire and they'll tape a little rag on it and then they'll drag it through. You know, all that kind of stuff. It pays off. It drains and drain cleaning, especially when you're doing an install. It pays off. You do not want to have to go back a week later because of a tripped float switch, backed up drain, water in the ceiling, because you just didn't clean the drain properly or you didn't follow these practices. Make sense? And I always say this to apprentices: become a really good janitor. Right? Like, I have cleaned more systems than I've done anything else, and it pays off. Just take that cleaning part seriously. I know it's not always fun. Somebody mentioned that, you know, nasty blower wheels, having to clean microbial, all that stuff. It's like, man, I get it. But you're preventing callbacks. So many of you mentioned callbacks. You're going to prevent more callbacks by making sure this sort of stuff is handled. Cleaning is really, really important. I'm going to comment quickly. How do you guys shut down the equipment with float switches? Do you do it on R or Y? You do it on R. That's my preference. I prefer R. In a humid climate, we want people to know when the float switch is tripping. We don't want it to cycle.
Unless it's communicating, it's supposed to break C using a relay, but so we break C usually.
Yeah, and in some communicating systems, they actually have dedicated terminals for it too. So on a lot of your Bryant and carriers, you actually have, you know, you're dedicated where you can use G, and then that will actually signal it that you have a float switch opening through the actual communicating control. So, what's that? Yeah, it depends on the system, right? Yeah. So you got to know, again, this goes back to RTFM. You guys know what that stands for, right? RTFM. Read the fantastic manual. The manual's fantastic, so you need to read it. Right? I grew up conservative Christian. My dad told me that's what it was the whole time, so I believe him. Read the fantastic manual. Yeah, it's a fantastic manual. In terms of the condensate switches, I'm a really big fan of redundancy, especially in cases where you have equipment in attics over top of spaces that they're potentially going to damage a lot. So making sure that you wire your switches in series with one another, not in parallel with one another. I know that's apprentice stuff, but really important. It wires into one switch, into the next switch, so that any one switch shuts the system down. Really important, right? And having redundant pan switches and equipment switches. Thinking about, and this is the way I tell people, step back from this unit. Imagine that water starts leaking everywhere. Where's it going to go? Is it going to run down the ducts? Is it going to think about where it's going to go and make sure that it's set up so it's going to get caught and it's going to shut the equipment down, right? Some of the biggest problems I see in attic units are pans that aren't big enough, they don't have enough overlap, they're not kind of held in place, so they get bumped, the switches aren't positioned properly, all that kind of stuff is really big. Do you ever run into cases where you guys use condensate switches, float switches, and you sit them right out the front of the unit like that, just to stub it right in, and then it doesn't actually raise the switch enough to even shut the unit off? Do you ever run into that? There's some systems, pieces of equipment, and again, you'll know because you'll go and it's dumping water, and the switch isn't fully, it's like not high enough. And so you have to know the equipment you work on. There were some Lennox units, there were some Ream units back in the day, and with the switches that we were using that just wouldn't actually raise the level. So we've taken to literally piping them around the corner, dropping them down in order to ensure that they fill with water. A lot of techs will say, well, that's a problem because the water can't get back out. Newsflash, the water's not supposed to get back out of a float switch. If the water's getting back out of a float switch, it means there's a problem. That float switch is there to fill up with water if there's a problem and shut the system off until somebody can come find the problem and fix it. Have you ever done this or seen people who they just like re-pitch the float switch in order to make the unit come back on? If you're having to tip the float switch up a little bit to keep the unit running, that's a bad sign. That means something else is wrong with the equipment.
What you mentioned a while ago about we call them nuisance calls.
Yeah.
A lot of times, a little bit of water might go inside the switch.
Right. Just tip it up a little bit. And it might run that way for years. Okay. But again, something else is happening. And usually what's happening is high static pressure on the system. So like, how is that related? Well, the more static pressure you have, the more turbulence there is of air. And so you actually get water that's actually jumping up over that dam and making it in. Find the source. A lot of times it's, we've even had manufacturers. There was a case back in the day with a particular brand of train coil, a particular model of train coil, that it was just set over too far. And like water would drip off of the coil after a while. And it wasn't a lot, but it was just a little bit. And we figured out how to just tip it up. Like we literally because it had 4 screws that attached to the top plate. And so we took 2 of the screws out and just like put the 2 in the place that the other 2 were and just brought it up just a little bit so that the water would run off the slant coil. And again, what's that?
I think those are the TAM4. Was it TAM4?
No. TAM4 maybe. I'm talking way before that. This was the TEZ coil, which is like, this would have been like 2002, something like that. TAM4 was the.
TAM4 had a really short grade line.
But the TAM4 is positive pressure.
Not TAM, TEM.
Maybe it was that. It may have been that one. Yeah. Okay. It's been a long time since I've dealt trains, so my brain's a little rusty back in those cobweb areas. But yeah, so you find these solutions. A lot of times it's like on horizontal units, reconfiguring the evaporator coil. It needs a shield, or it needs a special side flow kit, or the gooseneck has to be positioned in the right side. A lot of times it's goofy stuff like that. But again, find the source of the problem. Sometimes you're on a call, it's 10 o'clock at night on a Saturday. I don't know if you guys do 24-hour service here, or late night service?
What's that? We don't know.
Okay, I wish you didn't have to. But if you run into those situations and you got to just get it running, sometimes you got to do what you got to do. Okay, like no judgment here. I've done every stupid thing you can possibly do. But if it's a nuisance drain issue, there's a reason, right? And sometimes the reason is that the manufacturers are idiots. But usually it's some little thing that you're missing, and a lot of times it's airflow. A lot of times it's that the system has too high static pressure. Let's see, anything else? Go ahead.
Say a couple things on that.
Sure.
I did an install recently where So it was a positive flow coil, and I was like, oh, I want to reduce the air leakage. So I put a cap on my clean out, and the static pressure was so high that it would sling water out into the primary pan. And luckily I had to go back the next day, but the solution was just basically I had to take that cap off of that clean out. So yeah,
That is a really weird workaround. I'm gonna have to get my head around why that happened.
Huh? Why was the static pressure high?
Why was the static pressure high?
Because I did a bad job designing it. I was trying to fix it, but I didn't.
Yeah.
Yeah. So a company I used to work for, they would actually plumb the primary and the secondary together because they had this problem so much. So the secondary had a float switch, but then it would make a 90 back into the primary, so that if water ever came out of the secondary drain, it would still go down the primary. So anyway, and then another thing I was going to add is, yeah, if you've got like condensate pumps or multiple units draining into one,
Common drain.
It's like, okay, are all the units the same level? It is, if one unit shuts off, this was brought up to me recently, I did an install where I had to kind of think through this, okay, when one unit shuts off, what's going to happen to the other ones? Are they still going to be running?
Yeah.
Where's the water going to go if they're still running and
Right.
this unit's off? Is it going to fill up this other unit?
Right. No, and that's a very real consideration. This is pretty advanced thinking. Like, your average apprentice isn't probably going to think this way, but you always have to think about that. Whenever you have multiple drains coming in together, the most common one we run into is dehumidifier drains piped into AC drains, okay? So you have a dehumidifier, and it's a lot of times we have closet units. The house we're staying in has closet units, so I know it does exist at least somewhat. You have closet units, and then you put the dehumidifier in the attic, right? Because it's easier to duct in, it's out of the way, it's a place where there's space. Well, now, if you pipe that into the same drain as the AC, and you put a float switch in the dehumidifier, so if the dehumidifier backs up, it shuts off, right? That still doesn't solve, or sorry, the other way around. That doesn't solve the problem, right? If the AC shuts off because the drain's backed up, it's still going to dump in, and it's going to start overflowing the AC unit, right? So you have to interlock those somehow. And there's multiple ways you can do it, but one of the best ways we've found is to use a relay. We use a 9340 relay, and because you also can't just connect the two transformers to each other. That's another thing you see people do. It gets a little complicated. Go ahead.
Yeah, so question, Bryan. So I've seen cases where, like one time when I was an apprentice working with a technician, I saw a case where the float switch was connected to R. However, no, because of the sensitivity of that thermostat, like a S10 or a Nest,
Right.
like those are advanced thermostats. Like once that thing tripped, I've seen that actually kill the thermostat.
Mm-hmm.
So I'm wondering to myself, is it like really mandatory to just hook it up at R or hook it up at Y for those sensitive thermostats?
Yeah, you run into cases, and sometimes, yeah, there's some weird edge cases. I actually worked with, I still do. They just never call me anymore. I consult for Diversitech on a lot of their switches and things, and you run into some weird cases, especially switches nowadays that actually have some electronics to them and actually use some parasitic current in order to operate. And you'll get into some weird cases. Another weird one is you'll have some float switches that actually short themselves. They actually stay closed because the unit is drawing high enough current, and it actually causes the contacts to stay stuck. It welds the contacts, and that's on some multi-stage heat pumps where they have a higher current on R, and then in some cases you go to Y. So are there edge cases where you could go to Y? Sure. Alternately, you could do kind of what I'm saying, which is more complicated, but you could work through a relay, where now instead you're just opening and closing a relay, and now you're using the relay contacts to shut the system up on and off. Again, I don't know that that would necessarily solve that problem that you're running into with Nest. I haven't seen that particular issue that you're saying, but it's plausible to me. Yeah. Go ahead.
When I go back to the traps, right?
Here. Oh, back here. Yes. Okay.
The positive airflow indoor unit require a trap.
Okay, so the question from Tony here, the question from Tony is about positive airflow units do they require a trap? Well, Simon brought up a good point. In cases where you have a positive airflow unit that's attached to a sewer system, then you still need it. But otherwise, do you need it? The answer is, I would still do whatever the manufacturer says. In a lot of cases, they do tell you to use trapping. Okay, can it cause more problems? Sure. You do lose some air through the trap. If you don't have a trap, you lose some air through the drain. Does that matter? Probably not. It's not that big of a deal. In some cases, not trapping can actually increase your drain flow rates. But go ahead, Simon. What were you going to say?
No, I just gonna say the train. Like we only one positive pressure we give is train. And they tell you you don't have to, but they recommend it just for efficiency, so you don't lose.
Right. In some cases, rodents, or not rodents, like bugs, that kind of thing can be a thing. They're less likely to make it up into the system if you have a trap, you know. But is it that big of a deal? I mean, again, we do in our market just because the inspectors are looking for it. That's a thing in our market. In a lot of markets, like gas furnaces, are all positive pressure. In most markets in the U.S., they do not trap gas furnaces because it does actually reduce some drainage issues because now you don't have a trap to clean. Same thing is true of ductless, right? Ductless manufacturers, the vast majority tell you not to trap, that you can't trap. Which again, of course, you can trap anything that you want. That's always kind of funny to me when they're like, no, it will not work if you trap it. It's like if you trap it and vent it and have proper pitch, the water will still flow outside. But
Another question about the joints. When you have an open return, not ductile return, you require put a vent?
a good point, because now you're potentially going to have negative pressures. I've never run into an issue because you don't do it. Again, do you need a vent? You're saying a trap or a vent? You're saying a vent. Vent. Do you need a vent? The answer is you can get away without having a vent so long as you never have a double trap, right? The system will drain. The best practice is to have a vent. So in the case that you get one additional small trap, a belly, some buildup in the drain, whatever, it will still drain. That's the advantage. Will it? I mean, again, like the house I'm at right now, it's draining. It's working just fine, and it doesn't have a vent.
Talking about operator like that, over there.
Sure, right. I get what you're saying. Will it hurt it to have a vent? I've never run into a case. We do a lot of apartment equipment where it is open return, that kind of thing, and we vent afterwards, and it works just fine. Do you need it? Need's not the right word. Is it still the best practice? Sure. But again, that's where we're getting a little pedantic here. It's a little bit, we're getting a little fine there. I mean, whatever works for your market. Again, you guys don't have inspectors, so, right? You guys don't have any permits or anything like that on your installs? Only new construction. Okay. So you're doing change-outs. You're not having inspectors come in and look. So it's a matter of what works for you. Insulating horizontal runouts of your drains. You guys insulate all the horizontal portions of your drain lines here? You do? Okay. In this market, that's a really good practice. Your traps, your horizontal portions. And why horizontal and not vertical? Because vertical, the water is falling, it's not sitting. When it's sitting, the cold water sitting on the horizontal portions, that's where you tend to get a lot of condensation. And again, if it's in a space that's conditioned and humidity controlled and you don't have an issue, then okay, whatever. But if you're running it through an attic, you're running it anywhere that's unconditioned, anywhere that's not humidity controlled, you can get dripping. And you see this a lot in cases with ductless, whatever. Like for years, we had contractors in our area who were installing copper drain lines for ductless systems with pumps and just running them through attics. Well, over time, the suckers just drip. The drip, 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 and eventually you'll get a stain or you'll get mold growing or whatever. I mean, it's one of those things that doesn't show up right away. It takes a while, and so it's just a good best practice to insulate any horizontal runouts of drain in unconditioned spaces. Drain fabrication, again, these are code things, so like I'll reference things that are codes and all this, but one thing I see a lot of here is really poor line set covers, really poor sealing, and that can be a big factor, especially in the envelope. And again, you want to address issues that aren't just today's issues, but are like going to cause damage over the next 10 years. When I'm looking around a lot of the buildings, I see a lot of line sets just coming out of holes in the wall, just open. And you can see where water has run down in, and it gets inside the wall system, and it creates damage that you cannot see, and it builds up moisture in the structure that you cannot see. And a lot of times issues with buildings where they have mold issues or they have moisture issues are because of 1,000 little cuts, not one gigantic hole in the envelope. But when you have 1,000 little things that aren't sealed, little gaps and cracks and all this, it does allow for moisture to build up in the space, which then causes a lot of the problems that we see, right? And I'm sure you guys see that a lot. We recommend using line covers. They don't have to be like Speedy Channel or that kind of thing. They could be metal, whatever, but just making sure that everything is really well sealed. Ductless systems. You guys run into cases with ductless systems have really dirty blower wheels? You run into that nasty, that happens a lot. You're never going to fully prevent that. It's a thing because they get it built up an electrostatic charge because they're not made of metal. It happens. But having open penetrations behind the heads or that aren't well sealed, where moisture can come in and air can come in behind, makes it a lot worse. Cases where it isn't well sealed makes a really big difference. And ideally, and again, almost nobody does this, but ideally you would use foam to fill big cracks, and you would use an elastomeric sort of like water proof sealant over top of that once it sets up. Again, almost nobody does that, but that's a best practice to try to keep that. And for you guys, I'm going to focus a lot on how to prevent and solve mold and moisture issues, because it's not about, I mean, it's aesthetics, like it looks nicer, but I'm focused more on how do you actually address and prevent problems that are going to come in the long run. And so these are things that can be helpful. Also, trying to get condensate away from the building a little bit is just a good best practice, because a lot of times it does make it back up into the structure, and it can wick back up into those outdoor wall systems. Insects also, it's another good reason to keep things sealed. We already talked about a lot of this. Anytime you're going to install a system in a downflow or a side flow application, you need to have read the installation manual and specifically looked at the information about this, right? I would encourage you to really make that a practice, because a lot of cases, side flow right, side flow left actually makes a difference with how you have to set up the equipment. You have to swap things around. You have to move things. You got shields. You got the little hoses. You got different, it's all this different seal kits for downflow, whatever. Anytime you run into cases where it's abnormal from what you're normally doing, stop, pull up the manual, and look at what it has to say about this. And again, there's not, because a lot of people say, well, yeah, but can't you teach me how to do it? Well, yeah, it depends on the model. Like, it depends on the specific unit you're working on. So anything you guys run into, go ahead, Matt.
So some of the coils I've been putting in recently, they actually, it says, like, if it's a high humidity environment, you need to order this, like, extra kit.
Right.
And it's like 3 different splash guards for, like, the 3 different layers of the coil.
Yeah.
Yeah, that's in the guide.
Right. The accessory guides. Always pay attention, especially if you're going to take on a new line. And again, I have not been perfect about this, but if you're going to install a new model or you're going to take on a new line, read through and pay attention to the accessories and pay attention to the applications for those accessories. Because if it needs an accessory, it's really helpful to get that, ordered beforehand. Go ahead, Brett.
I'm just curious, what equipment is that?
That's good. Yeah.
Yeah, Daikin, all the same. So, and you guys do primarily Bryant, is that right? Bryant, okay. Yeah, and again, you're gonna see all different types. So yeah, it's good to pay attention. But again, whenever you're running into it sounds so basic, but people will ask me all the time, man, how did you learn all this stuff that you know? It's like, I just read manuals. I ran into a problem, and I pulled up the manual and I read it, and now you know it. And it really is that simple in a lot of cases. So when you're running into weird condensation issues where it's like, man, we come back here 3 times, the insulation's saturated, I don't know where the water's coming from, one of the first things you need to do is stop and say, are there accessories that were supposed to come with this unit? Were the proper configurations made for the application that it's in?
So I had one just like this where they had put the splash guard on it, but it had fallen down into the plenum, and the plenum had become saturated. I took a duct off and looked in there. The drain pan was laying down, or the splash guard was laying down. It soaked the bottom of the plenum, and then it drained into the drain pan, fortunately. But the drain pan seal, you know how you guys have the drain pan where it has a PVC and you kind of screw it on? Yeah. The drain pan seal had broken, so it was leaking out right where the connection was, and it soaked her whole ceiling and collapsed her entire ceiling.
Yeah. Yeah, and again, anytime it drains and condensate, it's like, gosh, the bad callbacks we have, the real bad ones, like the ones that haunt you, I would say 80% of them have to do with drains and condensate, which is why I focus on this super boring topic as much as I am right now. Cleaning them, insulating them, supporting them, trapping and venting them properly, wiring up the float switches properly, thinking about units that are connected to each other that are different levels, and dealing with that. All of those things make a big difference.
Maybe just come to if you only have one float switch, the location of it, because there's always a debate where that one float switch should be.
If you only have one.
Well, it means on the unit. It means either have someone else.
Not on the pad, on the drain.
You only have one. Oh, primary or secondary. Oh, okay, gosh. You guys are setting me up to get in an argument, aren't you? Well, you always have one in the pan. Okay, that's what he's saying. Yeah, that's what he's saying. And again, like, okay, so I'm going to give you my experience. My experience, and you're going to notice this, is like 5 years ago to 10 years ago is like where I was in the field a lot more than I am now. So now I'm seeing things from a much more high level. We always put them in the secondary, okay? And we have good luck with that. But again, making sure that it shuts the unit down is a really key thing about that secondary position. The downside to the primary, it's not that it's a bad idea, it's how you position it, and it's where is that float sitting in the drain. Because a lot of times, if it's sitting too low in the drain, where water is now running across that float, and now it gets gummed up, right? And now you can actually run into more issues. You can get into nuisance trips, you can have all kinds of things that happen just because you have this float hanging down in that primary drain. Can it work? Yeah, of course. I mean, it can work. It works all the time. I'm not saying it's a bad idea. It's just we do it in the secondary. And I prefer to have it in the secondary.
Well, the problem is that most of the time the part of the drain that doesn't get clean is the inlet, right?
Right.
The first part of the drain. If that blocks, the inlet's not going to help you.
Correct, and that is a good point. And then again, that's where you have your secondary drain pan. You have other things you can even use in some cases. And again, I encourage you strongly to look at the application. Right? Is this a situation where if this thing backs up, it's going to cause massive damage? Like it's a high-risk situation. Well, then be overkill. You have all kinds of options at your disposal. You can even use things like wet switches. There's all kinds of things you can use. And in that case, a nuisance service call, something tripping, is a lot better than having something get damaged, right? So just thinking through, and this is part of the sales process, just like, do you want to have redundancy? Because you can even put pan switches in the primary pan. That's another way. You can use a pan switch in the primary pan in some cases.
What is a wet switch?
Wet switch it's a little puck. It's made by Diversitech, and if it senses water at all on the bottom side of this puck, it shuts the system off.
So the water have to be like wet enough or something like that.
Wet enough? Yeah.
So you just put it down the pan and it just sends the water.
Senses water, shuts it down, right? And so that's a good, like in cases where, I'll give you an example. Let's say you guys probably don't run into much downflow here, but let's say you have a downflow system that's blowing down into a floor system. There's not like a great way to deal with that. You can't put a pan underneath it, really. So, but if you just drop one of those into the supply now, sitting underneath, now if it starts blowing water off and it starts saturating that duct, it'll just shut it off. So it's handy in cases where you've got weird cases like, man, I'm worried about this. You can use that. But I seriously doubt your leadership is going to have a problem if you're like, hey, I'm trying to prevent a problem here. Is there something else we can do? Have that conversation and just look at what your options are. But as a standard practice, we put it one in the secondary and then one in the drain pan underneath. But again, that drain pan underneath and how that's set up, like Matt said, that little seal there, right there was the weak point. We run into a lot of cases where it's suspended, and guys will suspend the pans terribly. Where as soon as it fills with water, the whole thing collapses on you or whatever, right? So you got to think about what's going to happen when this thing leaks. Where's it going to leak from, and where's that water going to go? Having overlap on all sides is a really big deal. It's similar to like, you look at a lot of systems where they'll install horizontal in an attic and they'll just attach the duct. You guys have a lot of ductboard here, right? Ductboard mostly, is that right? Yeah. Mostly ductboard, okay. They'll just attach it to the unit, and the only thing that's holding the ducts to the unit is the tape and a little bit of mastic, right? And eventually the ducts fall off on you. It's like thinking about all of that. What is likely to occur here? Making sure everything's well supported. Drain pan can't move on you. Float switch is properly positioned. All that stuff. It's that big picture thinking that's going to save a lot of those dumb callbacks like you mentioned.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.